Why is no one willing to admit that Oumuamua could be alien technology? Some of its phenomena seem to defy all physical common sense. Scientists say it's not a comet, not an asteroid, and may not even be naturally formed. So what is it? Why? Does every explanation seem to avoid a more dangerous truth? In this journey, we won't discuss mysticism, we will only discuss evidence in pursuit of a more accurate answer. But to truly understand the shock of Oumuamua, we must rewind time to the moment it first appeared. On October 19, 2017, the Pan-STARRS 1 telescope in Hawaii captured its silhouette. Initially, scientists thought it was an ordinary comet and named it C-2017 DO. Strangely, it didn't outgas and had no tail. A few days later, it was reclassified as an asteroid, designated a 2017 U1, but as calculations deepened, they found that this thing was traveling on a hyperbolic orbit. In other words, it was not orbiting the sun, but was accelerating away from the entire solar system. Therefore, scientists had no choice but to create a brand new category for it. It was officially named Oumuamua. This was the first time in human history we had witnessed a visitor from interstellar space. The name comes from the Hawaiian language, meaning first messenger from afar. On one hand, it honors the telescope that discovered it. On the other hand, it hints at its special identity as a pioneer. And from the first second of its appearance, everything was wrong. Its speed was too fast, its orbit too strange. It didn't look like an old acquaintance from the solar system at all, but rather like an intruder. It briefly swept past the sun, and even entered within Mercury's orbit. There, its speed reached an astonishing 54 miles per second, and then it was flung by the sun's gravity, flying into interstellar space without looking back. For a few short weeks, astronomers around the world rushed to observe and measure its behavior, and as it tumbled through space, people were astonished to discover that its brightness change was extremely unstable, as if a particularly elongated, or even flattened, object was rotating. Early estimates believed it could be up to 400 meters long with an aspect ratio of 10:1, like a cosmic cigar floating in space. But a further analysis of its light curve suggested another guess. It might be more like a space pancake, with a ratio between 6:1 and 6.6:1. Regardless of its shape, it doesn't look like any comet or asteroid we've ever seen. Its volume is not large, only a few hundred yards wide, and its surface is a deep red. This is likely the result of it being weathered by high-energy particles during its long journey in space. But what is most difficult to accept is that it had no out dust, which are typical for comets. As astronomer Karen Meech once said, even as it passed the sun, deep observations found not the faintest hint of dust around it, but the mystery had only just begun. Its orbit could not be fully explained by gravity. In its process of moving away from the sun, it exhibited a weak, non-gravitational acceleration, as if someone had gently pushed it from behind. Typically, the outgassing of a comet would cause this phenomenon, but not a single trace of gas was detected on Oumuamua. This plunged the entire scientific community into a contradiction. What exactly is a celestial body with no dust but is accelerating? Did it release some kind of matter that we can't see, or is it fundamentally not a naturally formed object? The public was quick to speculate. Could it be an alien spaceship disguised as a celestial body? While most scientists still leaned towards a natural explanation, every one of their hypotheses sounded a little unreasonable, and even contradictory. We only know one thing for sure. Oumuamua came, but what is it, and why did it come? No one could give a definitive answer. To solve Oumuamua's invisible acceleration, in 2020, two scientists proposed a very bold hypothesis. Daryl Sutton and Gregory Laughlin believed that Oumuamua's body might not be rock at all, but a substance made of a very rare material, molecular hydrogen ice. Their hypothesis is as follows. In the distant depths of the universe, there is a region called a giant molecular cloud, where the temperature is close to absolute zero. Celestial bodies similar to hydrogen ice mountains may be born there. This hydrogen ice would sublimate when it gets close to the sun, turning directly from solid to gas, without even needing a very high temperature. And this sublimation doesn't happen with the violent eruption of ordinary comets. It is a uniform and quiet, almost invisible release, as if the entire surface of the object hit a ring of invisible thrusters. Because pure hydrogen is almost undetectable in visible and infrared light, it will neither glow nor leave a trail of vapor or dust. So from the outside, it looks like an asteroid. But from its orbital performance, it is more like a disguised comet. This model is indeed very clever. It simultaneously explained two of the biggest problems: why it didn't outgas, and why it was accelerating. It could even explain Oumuamua's strange shape. The two scientists pointed out that continuous sublimation of hydrogen ice would cause the celestial body to slowly lose mass, and its edges would be eroded, and the overall proportion would be stretched. This may explain why it is so elongated, like a cosmic cigar. They also emphasized that this hydrogen ice can only be formed in the extremely cold and dense interstellar environment, such as the core of a giant molecular cloud, where it is closest to absolute zero. If Oumuamua really sets sail from there, It would not be strange for it to have drifted in interstellar space for hundreds of millions of years. And during this journey, it was gradually eroded by cosmic rays until it quietly entered our view. This scene is indeed fascinating. A primordial iceberg floating from the cold edge of the universe, with no tail and no sound, but carrying a journey of hundreds of millions of years. But this hypothesis quickly caused fierce controversy in the scientific community. In the same year, Thiem Hong and Davi Loeb published a rebuttal paper in which they believed that this hydrogen ice theory, while elegant, simply doesn't hold up. They pointed out that the starlight in the galaxy, even the dimmest starlight, with long-term exposure, would be enough to make hydrogen ice slowly sublimate and vaporize. They calculated and found that a hydrogen ice body the size of Oumuamua would completely vaporize within 10 million years. And the flight trajectory of Oumuamua suggests that its age may be over 100 million years. Just this point alone, the hydrogen ice model is self-contradictory. What is more serious is that if Oumuamua really came from a dense molecular cloud core, it must have passed through a large amount of gas and dust during its departure, and these collisions would have made it vaporize faster. It simply would not have survived until today. But the most fatal refutation was yet to come. Hong and Loeb pointed out that hydrogen ice is a material that simply cannot be formed, because the primordial particles of hydrogen ice are extremely unstable. They will be disturbed by starlight and heat before they can merge into an iceberg, and will disperse prematurely. The conclusion is very direct and cruel. A pure hydrogen ice body could not have drifted from the distant deep space, and even less could it have traveled through the solar system intact. It should have melted on the way, like a snowflake in the universe. This debate is the truest face of science. It is not about who is right and who is wrong, but a way to continuously use refutation to advance the truth. And at this point, the question returned to the origin. If it's not a hydrogen iceberg, what exactly is it? Just as one round of hypothesis and refutation cycled, the scientific community ushered in a new idea, which is the clue we are going to talk about next. In 2023, after the old hypotheses were overturned one by one, a new explanation finally surfaced. And this time, it made many scientists nod in agreement. The hypothesis this time was proposed by chemist Jennifer Bergner and a familiar name, Daryl Seligman. They joined forces again and gave a more realistic possibility. Oumuamua might not be made of some rare hydrogen ice at all, but a very ordinary frozen celestial body. But some unexpected changes happened to it during its 10,000-year interstellar drift. Their idea is this. This water ice-rich celestial body, while traveling through interstellar space, was constantly bombarded by cosmic rays. These high-energy particles can penetrate the ice layer and trigger subtle but real chemical reactions within it. We know from laboratory experiments that when water ice is irradiated, some of the molecules will break down, forming molecular hydrogen, and be quietly trapped in the ice structure. These gases will not escape, but will be trapped in the non-crystalline water ice, hidden in the pores of the ice body in the form of tiny gas bubbles. After millions of years, a considerable reservoir of hydrogen was quietly accumulated inside this celestial body. Then in 2017, when Oumuamua entered the solar system for the first time, it began to warm up, but not with a violent heating. Its surface temperature was never high enough to melt the water ice, and no water vapor was detected during the observation. But this slight warmth was enough to awaken the dormant energy within its body. After the temperature rose, the water ice began to recrystallize. The ice structure was rearranged, and the hydrogen that was trapped in the system was also released. This process is gentle and stable, but it can just form a slow and continuous thrust. Bergner and Seligman calculated that if this celestial body releases a few dozen to a few hundred grams of hydrogen per second, it is enough to cause the non-gravitational acceleration we observed. And what is even more brilliant is that this release process is silent. Hydrogen is extremely light and stable, so it will not glow or reflect, and will not have a tail or vapor. Even if there is dust mixed in the ice, those particles will also be sealed in the ice layer and will not fly out at all. So you get a kind of propulsion with thrust but no trace, which sounds almost like an invisible engine. This is an extremely elegant explanation. Ordinary water ice plus cosmic rays, forming hidden hydrogen, plus a little heat from the sun, can trigger a propulsion mechanism that is almost impossible to detect. It doesn't need strange substances, doesn't need complex conditions, and it completely matches all the characteristics of Oumuamua that we know. The dark red surface is consistent with the cometary debris that has been weathered by cosmic rays for a long time. No gas was detected, the volume is small, and the non-gravitational acceleration in the flight trajectory can also be explained. Ultimately, Bergner and Seligman gave this conclusion. Oumuamua is likely in essence an ordinary comet-like celestial body. It was just dormant for too long at the frozen edge of the universe. In that long drift, it quietly stored a kind of hydrogen drive in its ice river. and when it was awakened by the sunlight, it began its invisible escape. It had no dazzling tail, no visible reaction, but it used its actions to perform a truly authentic disguise. The reason why this cometary hypothesis became so popular is that it pieced together all the fragmented clues without having to resort to alien spacecraft, black technology, or exotic materials. Such a strange phenomenon can finally be explained by such a simple, elegant, and credible explanation. And this explanation also left us with a warning. Sometimes, the things that seem most mysterious may just be our misreading of their silence. And the story of Oumuamua might be like this. It didn't come to disturb us, but to remind us not to. Just look at the surface, and not to rush to conclusions. When we were still arguing about what Oumuamua was, another deeper question had never been truly answered. Where did it come from? Now we still have only some vague clues about its origin, but scientists have proposed several reasonable speculations. Back in 2018, astronomers tried to trace its trajectory backward, and the results showed that it may have been drifting in the Milky Way for hundreds of millions of years, until a certain accidental moment. It happened to get close to our sun. Its flight direction came from the constellation Lyra, near the area where the star Vega is located. But the problem is that when it actually passed there, Vega was no longer in that position. Because it had been flying for too long, even the position of the stars had long changed. So how did it leave its own star system? Mainstream opinion believes that it may have been kicked out of a young star system during the formation of planets in a gravitational battle. In the early stages of a planetary system, newly formed celestial bodies often collide with each other and compete with each other, and those huge gas giants, like a gravitational slingshot, can directly throw small celestial bodies out of the entire system at extremely high speeds and escape into interstellar space. In fact, our own solar system is the same. Gas giants like Jupiter and Saturn may have long ago flung away tens of thousands of cometary celestial bodies, forming the distant Oort cloud we see today. Then Oumuamua's home may have also experienced a similar scene. One or more rogue gas giants, like a cannon in the universe, threw it into a long cosmic journey. There is also another bold guess. Oumuamua may not have been thrown out, but was knocked out. It may have originally been part of an exoplanet similar to Pluto, mainly composed of nitrogen ice. The result was that it was shattered by a fierce collision, and it was one of the fragments that flew out. The interesting thing is that this theory also tried to use sublimation to explain Oumuamua's acceleration. But this hypothesis has more problems than the hydrogen ice model. Currently, the mainstream scientific community believes that its credibility is far lower than the mechanism of water ice releasing hydrogen gas. Now it is more than 40 astronomical units away from the Sun, 40 times the distance between the Earth and the Sun, far beyond Pluto, and it is still accelerating away. Now we are trying to turn from passive to active, from waiting for miracles to creating opportunities. The next time a messenger from a distant star system flies by our solar system, we may no longer just have to look up and miss it with regret, but can reach out and get closer to it. The problem is no longer whether we will encounter Oumuamua again, but when we will encounter the next one. And every interstellar visitor may bring a kind of awakening that transcends the Earth. A journey that breaks boundaries. A deep dialogue about the nature of the universe. We don't know where they come from, nor do we know where they will take us. But there is one thing we can finally be sure of. The next time a strange star breaks into our sky, we are already ready to welcome it.